Hello, in this video we're going to look at resultant forces in 2 dimensions. So in this worked example we've got an aeroplane that accelerates with a driving force of 400 newtons to the west, so that would be left. There is 200 newtons of wind pushing towards the south, so that's down. Find the resultant force, the overall force acting on the aeroplane. So step 1 is to draw a free body diagram, and all that means is a dot or a square on the page. When choosing the place to put your dot, bear in mind that you need to draw arrows coming from the dot. So you'll see what I mean in a moment. So for step 2, we need to convert 400 and 200 newtons into a sensible scale. So I've chosen 400 newtons to be 4 centimetres and 200 newtons to be 2 centimetres. So the blue line is going left or west by 4 centimetres or 400 newtons and south 2 centimetres or 200 newtons. But notice it's always drawn from the dot. For step 3, we're going to calculate the resultant force using a scaled diagram. So the difference here is I've turned the 2 arrows into a rectangle. So now we're going to draw a line from our dot to the other corner of the rectangle. And this is shown by the purple arrow. So to find the magnitude or the value of this resultant force, we need to use our ruler, and in this example it measures 4.5 centimetres. So the next part is to convert it back into newtons. Now earlier we said 1 centimetre was worth 100 newtons. This time we've got 4.5 centimetres, so that's then worth 450 newtons. In step 4, we need to remember that the resultant force has a magnitude, so 450, but it also has a direction, so we need to use a protractor. So unless you're told otherwise, you measure it from north, like you would in maths when dealing with bearings. And we need to find the angle from north that then meets the purple line that we've just drawn. So at the top, at north, I've written 0. And from this point, you can see from the green arrow, that is the angle that I'm looking to find. And measured carefully with the protractor, that will read 245 degrees. So as our final answer, the magnitude of the force is 450 newtons, and the direction from north is 245 degrees.